Hello everyone and welcome to class. In today's class we'll be looking at atomic structure. Okay, so let's proceed. Well, what is according to Dalton's atomic theory, atoms were indestructible solid particles. Well, however, experiments involving electrolysis indicate that certain compounds contain charged particles called ions, and then a series of experiments carried out led to the discovery of the fundamental particles of the atom, which are the electrons, the protons, and the neutrons. What atomic structure basically means is we looking into the structure of atoms, and we know that atoms are the smallest and indestructible particle of an element, and further experiments were further carried, and it showed us that atoms have subparticle. That means they are made up of the electrons, the protons, and the neutrons. We have a diagrammatic structure of an atom here, showing you the center, which is the nucleus, and that consists of the neutron and the proton, and we have the electron moving around the atom. All right, so it says that an atom comprises of a nucleus and an electron. Explain that. The nucleus consists of the proton and neutron, and the proton is positively charged while the electron is negatively charged. But the proton and the electron, they have the same magnitude. What do I mean by the same magnitude? Meaning that if in an atom we have that the proton is 5, that means the electron too is 5, but they have different charges. The proton positively charged, you could use P to remember that the proton is positively charged, so the proton will be +5, while the electron negatively charged is -5. Well, the neutron has no charge, but it has a relative mass of 1. All right, so let's move to the structures of the atoms of, I'm just giving you as an example. Let's just check the structure of the atom of oxygen. Oxygen has the electronic configuration of 2 and 6. The number of atoms in oxygen is 8. The atomic number of oxygen is 8. So it has 8 electrons and 8 protons, showing you that they have the same magnitude, electron and proton, but they just have different charges. So this is the diagrammatic illustration of the atomic structure of oxygen. In chemistry, we have the first subshell. It always the maximum number it contains is 2. It is called the S shell. So we'll move to the next shell, and then we said the atomic number is 8. So we've counted 2 in the first shell, so we have to count 6 in the next shell. And what you do is that you fill it one after the other. So after counting 4, then you add extra 2. But you can find out that there are two ions, or 2 electrons rather, that are not complete. So this is actually the structure of the atom of oxygen, and this shows the reactivity of oxygen. Oxygen will react with any element that will be able to donate 2 electrons so that we obtain a stable octet state. That's 8, and 8 is the maximum number of this shell. Okay, so let's move to the experimental discovery of the subparticles of an atom. First and foremost, let's look at the discovery of electrons. How was electron discovered? It happened that in 1897, J.J. Thomson showed that when a certain potential difference of about 5,000 volts was applied to a glass tube containing a gas at a very low pressure, the tube began to glow. And then on increasing the potential difference, the glow appeared on the glass. So he was able to prove that this glow was due to some kind of rays. He further called these rays the cathode rays. He then argued that these particles were particles that were present in all matter, and concluded that these particles must be the electrons proposed earlier by other scientists. And this experiment is very important because they provide us the existence of electrons, which carries fundamental unit of electric charge. So we also move to the discovery of proton. After J.J. Thomson's discovery of electron, he further stated that since we know that an atom is electrically neutral, so there must exist inside the atom enough positively charged components to balance the negative charge of the electron. So that's how proton came about. So he believed that if the atoms have negative charge, that means there must be a positively charged component to balance the negative charge, so as to give the make the atom electrically neutral. So this is J.J. Thomson's model of an atom. Let's further look at this scientist Rutherford's model of atom. Rutherford proposed a theory of atom. According to his theory, the atom consists of a positive core, which is the nucleus, where most of the mass of the atom is contained, and the electrons which move around the nucleus. Rutherford's model of atom was accepted by many, and he even had a Nobel Prize award for that. And so J.J. Thomson's structure, or J.J. Thomson's model of atom, was discarded. So now in present chemistry, it is the Rutherford's model of atom that is being used. That an atom contains of a positive core, which is the nucleus, and that is where the neutron and the proton resides. That's why it's positive, and then it has an electron which moves around the nucleus. All right. So with that being said, we've come to the end of today's class. Let's quickly look up at important points that we stated in this class. We said that an atom consists of subparticles. We said that the subparticles are proton, neutron, and electron. We also said that the nucleus of an atom consists of both protons and neutrons. All right. We also said that protons and neutrons and electrons, they have the same magnitude but different charges, and protons are positively charged while neutrons are negatively charged. So basically, these are the things we need to know about the atomic structure. All right, we have here an assignment. I would love you to try it and get a feedback from you. Thank you for today's class.